Okay, so this is going to be a worked through example of how we would go about doing the calculations and preparing a buffer to work with. So ideally, given the Henderson-Hasselbalch equation, pH equals pKa plus the log of the concentrations of the conjugate base divided by the concentration of the weak acid. Ideally, when we make a buffer, we determine what pH we want to make, and then given the pKa of that particular weak acid, we calculate how much of the conjugate base we need and exactly how much of the weak acid we need, such that when we mix them both together, we get the exact pH that we're looking for. Okay, so let's go through how we would actually do that calculation. So in this particular example, we want to make 5 liters of a 0.15 molar acetate buffer. We typically refer to buffers by their conjugate base name. So we want to make 5 liters of a 0.15 molar acetate buffer, pH of 5.00. And what we have on the shelf of our lab is 1.00 molar acetic acid, which I'm going to just represent as HA. And we have some solid sodium acetate, which I'll represent as NaA. And I can tell you that the pKa of acetic acid is 4.76. So pKa is 4.76 for acetic acid to lose this proton and turn into the conjugate base. Okay, so where do we even start? We want to figure out how much of the acetic acid do we need to measure out and how much of the sodium acetate do we need to weigh out, such that we mix them together, dilute to 5 liters, we end up with a pH of 5.00. So that's the question we're trying to answer right now. So we'll start with our Henderson-Hasselbalch equation. So again, pH equals pKa plus the log, the concentration of the conjugate base divided by the concentration of the weak acid. And I'm going to substitute in for the pH and the pKa, so we know that this value is 5.00 and this value is 4.76. So if I subtract 4.76 from both sides, I get that 0.24 is equal to the log of the concentration of the conjugate base divided by the concentration of the weak acid. So now what I'm going to do is I'm going to take the antilog of both sides. So if I take the antilog of each side, I get 1.7378 is equal to the ratio of the concentration of conjugate base, the acetate, divided by the concentration of the acetic acid. So that's great. I'm going to isolate this for one term, so multiply both sides by the concentration of the acetic acid, and I get 1.7378 times the concentration of the acetic acid is equal to the concentration of the conjugate base. And this is going to be my first equation. Okay. Now when we look at this equation, we have one equation, but we have two unknowns, the concentration of weak acid and the concentration of conjugate base. So that means to solve that mathematically, we're going to need a second equation. So what we also know is that this buffer we're trying to make has to have a concentration of 0.15 molar. So we know that, oh, I don't want to write in blue. That's crazy talk. So we know that 0.15 molar, the total concentration, has to be equal to the concentration of the conjugate base plus the concentration of the weak acid. So the way I think of this as total buffer molecules, the weak acid component and the conjugate base component. The total concentration then is this 0.15 molar. So here then is our second equation. So what I'm going to do then is I'm going to take the concentration of the conjugate base, which I solved for in equation 1 on the previous slide. So I solved for that in terms of the concentration of the acetic acid. I'm going to substitute that equation 1 into equation 2. So if I do that, I get 0.15 is equal to 1.7378 times the concentration of acetic acid. So that's my substitution for the conjugate base, plus then the concentration of acetic acid. So now I can solve this equation for HA. So I can, if I do that, I can collect terms. I get 0.15 equals 2.7378 times the concentration of HA, which tells me then that the concentration of the acetic acid has to be 0.0548 molar. So then I can take this value that I just solved for, and I can plug it back into either equation 2 right here, or I can use equation 1, and then I can solve now for my concentration of conjugate base. And if I do that, I get that the concentration of conjugate base is equal to 0.0952 molar. So what this is telling us is that in our final buffer, once everything's been made, the final concentrations of weak acid and conjugate base are these values that I've just solved for. Okay, so that's great, but that still doesn't tell us how much of each one we need to weigh out or measure out using a graduated cylinder. So let's take the case of the weak acid first. So again, the weak acid concentration needs to end up to be 0.0548 molar. So if I'm going to make 5 liters of buffer, so 5 liters of buffer, if that buffer is 0.0548 moles of HA per liter, that tells us how many moles of HA that we have. And I said that on the shelf in the very beginning, the problem statement, I said that I had 1 molar acetic acid sitting on the shelf. So that I know, I can do stoichiometry here, not stoichiometry, dimensional analysis, that I have 1.0 moles of HA per liter. So if I do that math, then I come up with that I need 0.274 liters of the acetic acid stock solution that I have. So 274 mils of my 1 molar acetic acid. So that's the first thing I need. Now let's figure out how much of the conjugate base I need to weigh out. So again, I know that the concentration of conjugate base that I need in the end is 0.0952 molar. So if we're going to have 5 liters of that, 0.0952 moles of acetate per liter, that's my conjugate base. That's how many moles of acetate I need. Now I don't just have acetate in a solid form, that doesn't exist, the anion by itself. I have sodium acetate. But I know from the chemical formula of sodium acetate that there is 1 mole of acetate for every 1 mole of sodium acetate that I have. And then if I just keep going over here, and if I look on the jar of my sodium acetate, I find out that it has a molecular molar mass of 82.04 grams per mole of sodium acetate. So if I do that math, I get 39.1 grams of sodium acetate that I need to weigh out. So now I know the physical amounts of the sodium acetate and the weak acid. So how would I actually make this buffer in the lab? Well, first, I'd probably weigh out the 39.1 grams of sodium acetate. Then to that, I would add my 274 mils of acetic acid stock solution. That was 1.0 molar. Then I would add some water, and I would adjust the pH as necessary. So this is all theoretical, right? Once you put the pH probe in there, your pH might not be right at 5.00 because there'll be errors in the measurements and from rounding. So you want to adjust the pH with a little more acetic acid or a little bit of base in order to get the exact right pH that you're looking for. Once that's done, then the last thing to do is dilute to the final volume. So dilute to a final volume of 5 liters. So you don't want to switch 3 and 4. You don't want to add all of the water and then check the pH, because if you have to adjust the pH with acid or base, you're changing the volume, which would be changing the overall concentration from 0.15 molar. So that's the general process for how to make a buffer, given that you have the weak acid and the conjugate base both on hand in the lab.